Good morning, my fellow scientists. It is Wednesday, March 29th, 2017. I want to talk to you about some of the literature I've been reading. I've been reading 2 papers this morning. I was preparing for lecture instead of in the lab, so try to make up for it with a little bit of reading. I've got a paper from 2006 on droplet generation using a very similar technique to what I'm doing in the lab. It came out of the Abraham Lee lab out of Irvine, California, and they did some simulation work and then checked how shear force affects the size of their droplets. And I think that's pretty exciting because it suggests that by increasing shear force you can reduce the size of the droplets, which is exactly what I'd like to do. It also had a couple of nice design elements, including a design that flares out after droplet formation. I think I'm going to try to incorporate that as well. Might also help with mixing. So yeah, fun ideas, and we'll try to incorporate those in the next run through. The other paper out of the Huang lab in Beijing is an article on using a microcentrifuge tube to generate droplets. So they made very small channels in a glass monolith and then spun that glass monolith with water behind it such that the water was forced through the channels by the centrifugal force and then broke up into droplets in air. Really neat idea. I'd love to try that as well because it gives them really high pressure, probably considerably higher than the pressure I'm able to generate with a syringe pump. But what really gives me hope is that their 7 droplet generators in parallel were able to produce a really large volume of micro droplets, comparable to what I would like to produce myself. So we're producing something like 100 microliters of droplets using homogenization, mechanical means. And I would like to produce that same volume using microfluidic means, but I've been worried that maybe there's just not enough throughput. But this suggests that if you can get the pressure high enough, you can have that kind of throughput. And we can definitely make 7 of these devices that we're making, so maybe we can do it too. So yeah, exciting times. One of the things I'd like to get into is some of the simulation work, and that may be a little challenging to get the right software, but I suspect it's a lot less challenging than it was in 2006. When I was in grad school, I tried to get into some of these simulations, and the software at the time had a very steep learning curve, and maybe it's a little better now. I suspect that that kind of software doesn't have a big driver for user friendliness, so we'll see. So thanks for tuning in. Keep in touch. Tune in tomorrow. We'll talk about more science and droplets and microfluidics and hopefully more results here in the On Lab.